Hi guys, let's take a look at the Pfizer Building in Manhattan, New York. 2 columns buckled because of extra floors they were adding on top of a 10th floor high building. Let's see what they were doing. We see here the building in the current situation, and this was the before situation, and we see that there was a piece that's in the current situation added. So we see that here. So this is the 19 floors that they are added recently. Here we see the current situation as well, but more in a front view. We see here also this piece that they added, and in total on the whole building they added 4 floors extra. So this is actually what they added. The problem with the buckled columns was just underneath the new floors. So actually in the columns that were in the existing situation, in the before situation, carrying only the roof. This one was supposed to carry only the roof. So in most situations, if it's only carrying a roof, it's a thinner column. This is a buckled column, and here beside is the next buckled column, and they buckled towards each other. And here we see a heavy beam on top of that buckled column that was carrying massive load because it has a huge span. So we are in a dangerous situation, and then we see that there are people welding, trying to reinforce the situation by adding extra supports next to the buckled column. You see here the buckled column, on the other side is the same situation, and here they added already extra supports, here also extra supports, and yeah, he's now busy. I hope he gets paid well by adding extra supports. Now look at it, it looks also this column has some issues, but okay, it's a really dangerous situation where they're working in. We see here the building in Google Earth, and what I saw here is that we can take some street view pictures. Let's see. And what I also realized is that the existing status of the building is not that good anymore. I mean, it's an old building, and we see here rusty beams visible from the street. And if we look at the other side, I saw that we could see here, you can see more or less the same kind of structure. So the beams look that they are made out of concrete, but this is just fire protection. So it's steel with concrete around to protect the beams from fire. And these beams, these columns actually in front in the facade, they are just to carry the facade, so these can be neglected. Okay, so we were talking about this part that they added, and this was a crucial on top of the existing building, so the 10 floors part. I put this piece into the calculation software. Okay, let's have a look at the model. We see here the color part is the new 19 floors on top of this 10 floor building. This was existing, this is new. And here we see this cantilever that we also see in the building. We see that here, cantilever. What's interesting to see is that the existing building was just meant to carry the roof. So these profiles are much thinner than the new columns on top. So they were designed to carry 19 floors or 18 floors actually, and these were meant to carry just a roof, but they're carrying now 19 floors. The existing one, the one that buckled, is much thinner. It's like a rectangle shape. And now let's have a look at the columns on top. They are square and they are much thicker. Of course, they are made to carry the load, but they were not made for that. So that's clear. Okay, and then the question is, why didn't the building collapse? Because this column and this column breaks or buckles, Remove them for now. We see a unstable situation. And that's most probably because there are, of course, 4 columns left around the building, but this building is also connected with the floors into the existing parts. So here, every floor is connected to the neighboring building. This part is the new part. It's connected to the sides. So it's standing on 4 columns, plus it's still connected to the floors of the neighboring building. So that's the reason why it didn't fall over. Now let's have a look at the reactions in the situation before the collapse. It's not really about the preciseness of the numbers. It's just to compare. So here we see really low numbers, which means that they are just carrying the roof loads. And these columns here, they were also designed for these same numbers. And what we see here is that the numbers with these 19 floors on top is actually 40 times higher. So that it buckled is not a coincidence. So we see numbers around 700 here on the front side and numbers around 550 here on the back side. Now let's see what happens when I remove these columns. Calculate again. Cheers. And let's take a look at the results again of the reactions. Okay, we see now that these ones went up, but just a little bit, so that's fine. Because of these columns buckled, they kind of disappeared. So these columns underneath barely carrying anything anymore. But what we see is that the supports here on the backside carry almost double the weight now. So I hope that they also put some supports here on the backside. This is a picture made from inside at a much lower floor, but we can see that the columns in the middle parts are heavier. Okay, and now let's see what happened, or what happens in the situation right now where they place the new supports. Here we see this reinforced situation. So the supports are more or less here. Okay, and we let him calculate again. Okay, and there we see that we are back in the old stage again. The only thing that we don't know is that if the profiles here below these columns are the same as the ones that buckled, then there's of course the same risk here. Okay, and then there's another issue in this solution, is that the full weight of the building comes down on this location and needs to be transferred by this beam towards the support to another beam and then onto the next column. And that's not how the building is designed. So there are 2 places with a huge risk still. So if we take a look at the bending moments, so for example, this beam is designed for a bending moment of, let's say, 10. But because the new construction, these new supports that they placed here, the reinforcement, makes this beam having a little cantilever here. But because there are 19 floors on top, it's going to make a huge moment, bending moment in this beam. So let's have a look. So it went from 10 to a maximum bending moment here of even 200. So the columns might not be at risk anymore, but the beams are at risk. I was having a look about what the final design would look like, and I see that they wanted to add a rooftop pool. So we can say that we can be lucky that the columns buckled now and not later, which would have led to a full collapse, of course. Alright guys, thanks for watching. I hope you liked it, and see you in the next video.